Good morning, good afternoon, everybody. Welcome to today's webinar. This is a really interesting topic today. We are joined by Rick, 3D scanning specialist from Rapid Scan 3D, one of our Geomagic partners in the US, and also joined by Vishnu, applications engineer here at Oqton. They are going to be talking you through automating the inspection of injection molded parts using Geomagic Control X and the Artec Micro II. Before we get started, if you have any questions as we go through this webinar, we've left around 20 minutes at the end of the session to make sure that you get all of the information that you need. The presentation portion of this webinar will be around 35 to 40 minutes long. So if you have anything that you would like to get answered as we go through, please drop it in the questions area of the GoToWebinar control panel. I will be joining again right at the very end to field the Q&A to Rick and to Vishnu. So without further ado, I will pass over to you guys. Take it away.
Excellent. So my name is Rick with Rapid Scan 3D. I am an Artec 3D reseller. I'm actually an ambassador or a gold star reseller for Artec. And basically, we're going to go through the quick process of scanning a injection molded part with the Artec Micro. The part is about, let's say, 12 centimeters by 10 centimeters by about 4 centimeters thick. And we're just going to go quickly inspect this. A couple of basic features about the Artec Micro. It is a structured light scanner. It has white LED bulbs for projecting the grid onto the part. It actually has 4 13 megapixel cameras, accuracy plus or minus 5 microns with repeatability accuracy of 2 microns. Collects 1 million points per second. Is basically mostly fully automated for 3D scanning. As far as the data processing, that right now has to be done manually in the sense that you have to press 2 or 3 buttons to make your mesh. But according to what I've heard from the Artec people, they are going to basically make it to where it's a one-click automated processing and possibly even the scanning to the processing, which will let you send the file from one click directly through scanning, through processing, directly into, let's say, Control X for an inspection.
Good morning, everybody. I am Vishnu Balakrishnan, application engineer at Oqton for the Geomagic set of tools. Geomagic Control X here deals with the input from the scanner to perform your metrology applications. Geomagic Control X is a professional grade metrology software in which we can perform a wide variety of metrology and quality inspections. And Control X specifically is designed to interact with a wide variety of CAD and scan file formats. You can also scan into Control X directly by integrating with any different type of scanners and probe arms. The software interface of Control X is also very CAD-like. It's designed to be very intuitive and quick to learn and requires very less time to master it. And we have also added and equipped the tool with a lot of inbuilt capabilities to perform advanced things like feature recognition, which makes the dimensioning and other metrology process very easy and also very quick to use. Hence, in this session, I will be interested in showing you on how we can go with the CAD data we have, which is used for manufacturing, and the scan data we would be getting from the scanner, to getting a complete inspection report, and also using the embedded automation capabilities within Control X to automate this procedure so that we can automate the inspection of the further parts that are manufactured, so on. And With this, I would like to pass the mic back to Rick and Guy, who would be showing on the scanning processes and the procedures in detail.
Thank you, Ishni. So as you can see, the injection molded part that we are going to scan today is basically the back cover for a like a remote sensor that goes on a wall for a garage door opener. It has some pretty small features on it, and the Artec Micro is a perfect scanner for getting very fine details on smaller parts. It can get basically parts as small as, let's say, 2 centimeters by 2 centimeters, all the way up to about 20 centimeters. That's about 7 inches that can fit on the platform and basically be scanned at one time. So on a part like this, we're looking to do a first article inspection. Also, we want to set up a repetitive inspection using a CAD model to ensure quality of the actual injection molded part to fit within certain parameters and tolerances that we need it to fit it within every single time. And that's kind of what we're going to do. We're going to scan it, do an initial inspection of the part, and then use that to do a repetitive inspection on multiple parts that are the same thing. So we're gonna go ahead and start the process of scanning the part. As you can see here, the Artec Micro II is a desktop scanner. It comes with actually a few different parts holders. The one we're going to use for this one is basically, it's a twistable clamp. I actually printed a couple of holders that you can because the clamp has bolt holes so you can mount your own. So once we're ready to start, you click on the scan with the Artec Micro. It's going to initialize the scanner. Once it is initialized, we are going to calibrate the scanner, which only takes a few seconds. So the calibration does not need to be done every single time. Generally, if you're sitting on a desk, you only probably need to do it at the most once a month. But again, if you want to validate the accuracy, it only takes a few seconds to calibrate the scanner. All right, so once that is done, we're going to go ahead and mount our part on there. As you can see, we have a number of different holders. A couple of them have the ability to, in essence, put other types of clamps on there or use bolts to hold things down. They also have another holder that has 3 axes on it, which I use very rarely, but gives you a lot of options on how to hold the part. Again, for this one, we're just going to use this twist clamp, if I may, where I actually made a couple of little 3D printed holders to try to minimize the amount of area that the part is being touched. Once we're ready to go, we're going to just adjust the exposure. Basically, the idea is to be right around a little bit of red up in the black box. The best parts to scan are white parts. If you do want to scan darker parts or very shiny parts, we do recommend a spray like A-Sub, but just depends on how you do it. Sometimes it is not necessary. There is a number of different automatic scanning paths. You can do the default paths, which are large complex, all the way down to small simple. They basically add more angles of individual scans for the more complicated. You can also do single frame. just to get an idea that you're getting the part well. It even has an automatic setting where it just takes as many pictures as it thinks is necessary, or scans, if I may. So that data looks really good already. I'm very happy with it. That was just one individual scan. It actually collects color as well, and that's what you originally saw. Once we're ready to go, again, I can design my own paths if I want, but for the purposes of this webinar, we're just going to do small, simple, and it's going to take 32 individual scans from different angles. And we'll go ahead and speed up this part. There are 3 different speeds. You can go a little bit faster if you'd like. Generally, the scanner in essence makes a little bit more noise, if I may. The motors wind a little, but you can scan a part like this with 32 scans. Takes about 1.5 minutes to 2 minutes in the normal setting. You can speed it up, like I said, with the faster setting and get it down to about 1 minute and 15 seconds. Or go slower if you have something that has a tendency that move, that it's very fine, very thin, you can slow that down. But there's our first scan that is done. Generally, if you have a correct holder, you could probably get 95 to 98% of the data in one scan. But if necessary, because you're missing some area, it is very easy to flip the part over, grab it from the data from the other side, and then just rescan it and align the data together. It really just depends on your application and what areas you're looking to capture. In this one, we're going to go ahead and show how it's very easy to align another set of scans, or even if you wanted to, multiple scans. But the idea would be to make this as automatic and straightforward as possible. Depending on how you have your holder or a design of your holder, you could probably, again, get most of the data in one scan, because the scanner actually goes upside down and can scan from pretty much 360 degrees. And again, to minimize time, you can design your own scan paths. And if you do it correctly, you could probably get most of this data in probably 15, 16 scans, which would obviously improve the efficiency and the time. So again, we have our second set of scans here. As you can see, we have Micro 1 and Micro 2. We're going to quickly start processing the data, erase the data that we don't need. And there's a number of different selections. 2D selection, they have a lasso. You can also remove the base. Just quite a few different sets of erase tools. But again, the idea here would be to make this as automated as possible, which Artec says is going to be very easy to do in the next version. Depending how you do it, you don't always have to worry about getting all this smaller data. It will be eliminated in the processing of the data. All right, so we have the data cleaned up, and we're going to go ahead and move on to the next step of aligning our two parts together. The software, and unfortunately, I just cut off, the software does have the ability to do automated alignment. It can take a minute or so, depending on how much geometry you have. Again, for the webinar version, we're just going to click 3 quick points. Sort of put it in the region of each other, hit align, and then the software quickly looks at the data and aligns the scans together. And this is the initial step before we register all our scans together and create our mesh. So we'll go ahead and move on to the registration. We're going to use global. Global is basically going to align all the scans that we took together. There's the ability to do fine if you want, which is the individual set of scans. We can use geometry and the color. Generally, I think with the Micro II, it's generally only the geometry, and that's what I would recommend. But we're going to go ahead and do global. We're going to use all 64 scans and do a collective. Here I'm showing you that you can actually do a separate then collective, which is the individuals scanned separately and then the whole set of scans together. But we're going to run them all together. All right, we're all done. All the scans are aligned together, and we are now ready to make our mesh, which is called Fusion. There's a number of different ways to do Fusion. I am generally a person that likes to use Sharp for metrology or getting the best scan. The main reason for a part like this is I do not want to do any hole filling because I don't want the software guessing my data. So then I go ahead and run my Sharp Fusion. Again, depending on your part, this could take a couple of minutes or so. This part should be speeded up. Excellent. And there is our mesh. Again, a very good detailed, high accuracy mesh of the part. Once we're done and we're happy, we feel we have all the data, we can now export this directly into Control X. And that's really the basics of scanning and processing the data. Like I mentioned, most of this will be able, if not all of it, be able to be automated in the newer version of Artec Studio 19, which is coming out in a few months. There are other features in Micro. If you wanted to add the color back to the part, you can do that. You can take some basic measurements, but generally the scanner is best for just scanning. I'll pass it on to Vishnu.
Thank you, Rick, for the nice demonstration on how we can scan using the Artec Micro II scanner. So now here today, I am going to show you on how we can use the scan data that comes from the Artec scanner to perform a very short and simple metrological assessment. So here I have a version of Geomagic Control X 2024.2 open. And here I have the CAD file imported, which contains all the dimensions and relationships between the various features present in the model. The CAD file served as a blueprint for manufacturing this particular part. And I have also procured the scan data in advance and have imported the scan data within Geomagic Control X. So I'm showing it now. The scan data is the part in blue. Since Control X works with almost all different CAD and scan file formats, it's very easy to work with different CAD tools and a variety of scanner packages with Control X. Since metrology is the process of comparing the CAD file and the scan file together, we can see that the body, the scan file, has not come aligned with respect to the CAD data. And Geomagic Control X provides with a dedicated set of tools and capabilities to align the bodies in a seamless fashion. So here, I'm going to perform an initial alignment, and this tool would select a few points on the scan data and very automatically overlay it on top of the CAD file. So I'm going with the quick option here, and you can see that right away the scan and CAD are overlaid on top of each other, and it moves exactly on top of the CAD. So this is the first step in moving the scan data as close as possible to the CAD data. And Control X also has a set of further advanced tools here to fine-tune and optimize the alignment we obtained from the initial alignment, such as best fit, datum, RPS alignments, and so on. So in this case, I'm going to proceed forward with the best fit alignment. It's a very good strategy, especially in models where the scan does not contain a lot of analytical features. So this tool basically asks Control X to move the scan by applying small transformations to the scan, hence by minimizing the average deviation between the CAD and the scan in an iterative fashion. So here I'm going forward with this alignment method. This would refine the alignment that we obtained from the initial alignment and would provide us with a closer match to the CAD data in terms of alignment. And since we have performed our best fit alignment, at this stage, we are in a good position to start our comparison processes. And in regards to the comparison processes, we have a wide variety of tools in this bin as well, of which the 3D compare capability is a very important tool. So this tool would provide us with a good idea by providing us with a complete heat map of the deviation between the CAD file and the scan data at each particular scan point. So here we can kind of go ahead and set the max and min ranges. So I'm adding a max range of 0.25 and a min range of negative 0.25 for our color scale. And I'm adding a specific tolerance of 0.025. So here we can see that we have gotten a complete heat map, and we get to see a complete and wholesome information on what is happening across the model and the scan. We can identify the regions where the significant deviations are occurring, as well as the directions in which the deviations are occurring. So here, diverse occurring deviations in each directions are obtained, and the top two of them are added as an annotation to this particular report. And once I have the results of my 3D comparison, we can position the annotations appropriately, which would provide the reference positions in the Cartesian system on where those deviations are occurring, and I can add them to my report. And once I have added my 3D comparison results, we can proceed forward. We have the comparison points capability by which we can pick the points in these colored zones and kind of add them as labels to the screens. We have a variety of picking methods. So here I'm gonna match my color scales to be the same as the values in the 3D compare that we had performed earlier. And I can pick points freely within the scan data now. So I can pick this point in this turquoise region. I can select it and drag it out. I can select this comparison point in this yellow region, select it and drag it out. So here we can see that we have a variety of colored zones. I'm adding one for this blue region, which is deviating significantly, and one for the red region and the orange region. So we can mark any particular points of interest or each of these regions of interest, space them out neatly. And by doing this process, we can see that we have a variety of these colored deviation zones, and we can add these flags and associate them with a numerical value. And after we have performed this, we can add the comparison points that we have established into our report as well. So once we have performed this comparison process, we have the capability to perform a few other types of comparison process, like sectional comparisons with 2D comparing boundaries, etc. But coming to more streamlined and organized metrology processes, dimensioning and GD&T are a big portion of that. So we have the capability to perform those and a dedicated tab for them in Control X as well. So here we can do both 3D and 2D GD&T, and we have the capability to add linear, angular, radial, and elliptical dimensions with relative ease in Control X. We can also add datum flags and GD&T callouts very quickly and very easily using this software as well. So let me show you the procedure to add a few dimensions to this particular CAD model. So here we can freely select the faces that we need to add our dimension on and can drag and drop it. And we can choose to add our tolerance values of interest and say, okay. So here we can see that the flag contains a linear dimension. The reference value is represented in the dimension, and we have also added the measured value here along with the tolerance. A green flag indicates a passing deviation. The reference value is computed from the CAD file, and the measured value is calculated from the scan data by automatic parafitting algorithms within Geomagic Control X. Now let's add a few more dimensions here. I'm adding this linear dimension quite easily. I'm just picking the faces and dropping them to the side, adding my tolerance, and I'm saying, okay. We can also perform center-to-center type dimensioning. For example, I'm doing a center-to-center dimension between these two cylinders. I'm taking those features, dragging it out, adding the required value of tolerance, and saying OK. And a red flag indicates a failed inspection. And the same applies for radial dimensions. We can apply radial dimensions on features like cylinders, spheres with relative ease. The same procedure applies here. We can add our tolerance and say, OK. Let's add the radial dimension for one more cylinder over here and provide it with a requisite value of tolerance. So this is how we can very easily add dimensions in Control X. There is no requirement to explicitly construct and fit features and measure distances after that. Now, once we have added the required dimensions, we can add it to our report and proceed forward on to performing the further processes, which would be adding our GD&T callouts. We also support 2D dimensioning and sectional dimensioning. And coming here to the GD&Ts, a big part of it is adding datums. We can start by selecting the faces, clicking and dragging to make datums like this. So I made a datum A here, and we can also make use of features. So I'm gonna select a few points here and develop the central point on the cylinder. I'm going to repeat the same process on the other cylinder and construct a vector. So this is how we can construct features in Control X and use that constructed vector as my datum B. So here I can click on that vector, drag the flag outside and label it as datum B. And I'm gonna choose this internal cylindrical axis for datum C. So I'm gonna click on that face and automatically we can label datum C as so and say, okay. So here I have my 3 datums marked and labeled legibly. Now I can drag them to their appropriate positions, and then add them to my report if I want to have it as a separate page. And starting from here, I can start adding my GD&T callouts. We have the form-related GD&T callouts. So here I'm adding a flatness callout to this particular face. I select that face, add my required value of tolerance, and say OK. And for features like flatness, I can also show the fitting deviation between the CAD and the scan data here. So here I have added this flatness callout with the fitting deviation. Moving on to the orientation callouts, we are adding a perpendicularity callout here, and we can add the reference datum. So I'm making it perpendicular with respect to datum A and checking with the tolerance of 1 mm and say, OK. All different callouts as per the standards can be added in Control X. We're adding a positional callout here. We just click on the face and we can enter our requisite value of tolerance, followed by adding our required primary, secondary, and tertiary datums. We also have the ability to add the material conditions within this particular software. And once we have performed this particular process, we can add that GD&T callouts to our report and so on. So here, now we saw how we can input and make use of the CAD file and the scan file, which would be the manufactured part that came from the scanner, and perform alignments and do comparisons followed by dimensioning and GD&T. And once we have completed this process, we can generate all of this information as a report, and we can choose the items that we require here. So I'm removing the constructed features, and I'm generating a preview of a report. This report can be changed based on the template you want to have. So here we have the reference data with all 4 views. Following this, we are choosing to add the measured data, which is the information from the scan file in all 4 views, the 3D compare heat plot, as well as statistics showing the deviation, the information on the comparison points, and the information in tabular format. And here we are adding the dimensions, the datums, and finally the GD&T callouts that we are interested in. We can export this particular result in PDF, PowerPoint, Excel, and XML formats very easily with a single click. So now we saw how easy and intuitively we can make use of the Control X software here to generate our report and go from CAD and scan to a complete inspection report. And since we have performed this process one time, we can use the embedded automation capabilities within Control X to perform this process in an automated manner. So we are going to look at the automation server approach in Control X, where we can make Control X scan for a file that enters a particular folder from a scanner. And once a scan file enters this particular monitor folder, Control X has the capability to use the new scan data and perform the whole inspection on the second part automatically by itself. In order to perform this, we need to establish a folder system as shown here. We have 4 empty folders: communication, monitor, output, and template. And the communication folder is used to store the communication logs. The monitor folder is where the output from the scanner, that is the scan data, would enter in. The output folder would contain the completed output, and the template folder present below would be containing the template Control X file that would be used for performing the inspection. So we are at this particular stage now, and for the first scan, we would make our template file, which would look like this, and we can come and delete the scan data from this particular file. So here we can regenerate the results, and post regenerating the results, you can save this as a separate template in the template folder. So I'm saving it as in the template folder with the name of file_1. And once this file is saved, we can close Control X and exit out of it. And as you can see here, we have two executable files. One is the server and the other is the client. And these can be found in your Geomagic Control X installation directory. They come with it directly. And let us launch both of these tools here. And here we have the server and the client. And for the server, we see that there are two options, single source and multiple source. Single source is used where we have the scan file coming in as a whole from one source, and the multiple source approach is used where we have scan files that are shot that are coming from multiple sources, that are coming from 10 different angles or something like that. So here we are proceeding with the single file approach, and we can set our options here. We need to basically point the file paths for our monitor folder, template folder, and device and identification rule, which we can edit here. So here we have 4 columns, namely we have to add the name of the template file. The star.stl implies the file format, anything within format STL or extension STL entering the monitor folder would be used to perform the inspection, and the target result data that you would be using for performing the inspection. We can also choose to save the Control X model file if necessary, the file format of the report that you want to export, and set a path for the output folder where the completed inspections would be exported. So here I've set all of this up and I'm going to apply it. And over here, we have our client. We have our Control X automation client. We can set this with the default path for the Control X executable. And after that, we can say start server. So here I'm starting the server. And once we start the server, we can check for the availability of a Control X license. And after that, we can click on the connect button. So when we click here on the connect button now, this process would automatically connect the client and the server together. Now, once this type of a connection is established, as soon as a scan file enters this monitor folder, Control X would be opened in the background and the inspection procedures would be performed based on the item selected in the template file. So here we are taking a file and we are dropping it on this particular monitor folder. And we can see that Control X would be opened here in the background, and the scan file would be queued to perform the inspection. And the scan would be imported, aligned with the CAD file present in the particular template file, and all of the inspection process that was devised in the template file, like 3D compares, dimensioning, GD&T, 2D compares, sectional compares, whatever was made in the template file, they would be promptly performed and the results would be recalculated. The desired form of the report would be generated and exported. So we can see that the results are recomputed here and Control X has closed itself, and the requisite information after the inspection is complete can be found in the output folder. So here in the output folder, we have the report in the PDF format for our second part. all the components that we chose in the template report would be added here. And the Control X model file is also saved in the background. So this is how we can set up the automation server post performing a template Control X file for one part and automatically repeat it for n number of parts by just dragging the scan files into the monitor folder. So here we saw on how we can go from the scan data to performing an inspection, followed by the automation procedure using the automation server approach. Thank you so much.
Thanks, guys. That was super interesting. It's great to see how those two tools can work together. We have some time now for a Q&A. If anyone has any questions on anything you've seen, any questions on the Micro II or Control X, then feel free to drop them in the questions area of the control panel. It looks like we've got a couple coming in here. These first two, I think, will be for you, Rick. Is the scanner ISO certified?
Yes, the scanner is ISO. It is ISO 12836. So it is a metrology grade ISO certified scanner.
Great, thank you. And the software that you were showing as part of the scanning process, what is that software?
That software is called Artec Studio. It is the native software for the scanner for the Artec Micro II. It basically handles all the scanning and processing of the data. They have a new version coming out in a couple of months. I would say probably early October, late October, called Artec Studio 19. It is basically with new tools, and supposedly it's going to have a lot of more of the automated processing and scanning for the Micro II.
Right. And the last one that we've got here is, you were mentioned earlier about scanning of shiny parts. Can you talk through that process, how that works with the Micro II?
Sure. Yeah. So generally it depends on how shiny it is, but most, especially white light scanners, struggle a little bit with shinier objects. We recommend a dulling spray. We sell a professional scanning spray called ASUB that adds a very, very light, very thin layer to the part that lets the scanner then capture the data much more accurately and with much more precision. But generally, structured white light scanners struggle with shinier objects, especially if they're milled. That's always can be an issue. It might capture the data. I would always be a little bit worried about the accuracy of the data, because anytime you add reflection or something that is very shiny black, which means that it absorbs light, it's not going to reflect back correctly. And that's where the sprays come in. It adds a lot more accuracy to the scan. Great,
thank you. That looks like all of the questions we've got in the Q&A here. I'll do one last call. If anyone has any questions, feel free to drop them in the chat. If you think of a question at a later date, feel free to reach out. I know that Rick and Rapid Scan 3D will be reaching out to everyone on this webinar anyway to understand and ensure that they have got their questions answered and have got what they wanted from this webinar. So with that, I will say thank you to Rick, say thank you to Vishnu. Thanks for your time. Thanks for that presentation. And we will see you again very soon.